Hello, I'm Davis Binger, and let's talk about integration by parts. Today we will be looking at problem 6 of the 7.2 handout, in which we will evaluate the integral from 0 to 1 of x squared e to the 3x with respect to x. Note that this function, x squared e to the 3x, is a product of a polynomial function, in this case x squared, and a exponential function, e to the 3x. As such, it is a perfect candidate for integration by parts. Recall the general formula for integration by parts. The integral from a to b of u dv is equal to uv, evaluated from a to b, minus the integral from a to b of v du. In our case, we will let u equal x squared and dv equal e to the 3x dx. Taking the derivative of u, we find that du is equal to 2x dx, and taking the antiderivative of dv, we find that v is equal to 1/3 e to the 3x. Now we can take these components and plug them into the above formula. And we get that the integral from 0 to 1 of x squared e to the 3x dx is equal to x squared e to the 3x over 3 evaluated from 0 to 1, less the integral from 0 to 1 of 2x e to the 3x over 3 dx. We can pull out the 2/3 of this integral, but we're still left with an integral of a polynomial function times an exponential function. We are integrating from 0 to 1 x e to the 3x dx. We will have to perform integration by parts a second time to solve this second integral. In this case, we will let u tilde equal x and dv tilde equals e to the 3x dx. Taking a derivative of u tilde, we get that du tilde is equal to dx, and taking the antiderivative of dv tilde, we get that v tilde is equal to 1/3 e to the 3x. Now we can plug these into the formula for integration by parts, and then plug this formula into our previous equation, and we find that our integral of interest is equal to x squared e to the 3x over 3 evaluated from 0 to 1 minus 2/3 times 1/3 e to the 3x times x evaluated from 0 to 1 minus the integral from 0 to 1 of 1/3 e to the 3x dx. We have finally reached an integral that we can perform. Exponential functions are of an elementary nature, and we can find their antiderivatives. Thus, the antiderivative of e to the 3x times 1/3 is e to the 3x over 9. After some algebra, we will take the antiderivative, multiply through by 2/3, and then we will evaluate everything from 0 to 1. We arrive at the following expression, which simplifies to 5e cubed over 27 minus 2 over 27. Alright, thank you for watching. As always, you can reach me by leaving a comment below or emailing me at binger@math.ohio-state.edu. Thank you, and have a good evening.